great philosopher, Mr. Nick Bostrom. So, the main objective of our Intelligence and Machine Learning Club is to raise awareness and empower members to harness the power of AI through socially good projects. AIML Club encourages interest in machine learning research, and our aim is to promote the application of machine learning and artificial intelligence in the interdisciplinary areas. It creates a great environment for students to discuss and learn about various parts of machine learning and artificial intelligence. We encourage our club members to apply the knowledge gained from club meetings to pursue research in machine learning. The club also provides students with resources and guidance to explore specific fields of AIML, allows for networking between club members for possible project or research collaboration. These activities make the club members grow unique and make the members well prepared for what the future holds. While putting these facts forward, I would like everyone gathered here to know more about our artificial intelligence. Now, I would like to invite our HOD, Dr. Jabashila ma'am, to facilitate our chief guest, Mr. S. Chandrasekar, Engineering Manager, Tekion India Pvt Ltd. I welcome you, ma'am. Over to you, ma'am.
Sir,
Yes, ma'am. Can I start?
session is well, sir.
Yeah.
You will start. Sir.
Yeah. Okay. Thank you, Saravana Priya. Right. Okay. Thanks for the warm welcome, and thanks, Josephina Leela ma'am, for inviting me to take this guest lecture. So it's a great pleasure to take sessions for the students. So, ma'am, can I know, like, so this is BE Computer Science Department, right? And so, what is the total strength, ma'am, here?
42.
42. Okay. Because I could see 50 people have joined the meeting. So, students, let me start. So, I just want this session to be more of an interactive session rather than just you guys listening to it, whatever I say. So, you just, I'll kind of ask few questions so that you can also be interactive. So, don't just keep silent or don't just watch. Listen to whatever I say. So, whenever you have questions, you can raise your hand and then probably you can shoot out your questions. So I will be able to answer that. And so basically, I just wanted to share my experience, like how I worked in different companies and what are the different kinds of projects I worked for, and what is the process that we follow in the software industry. So as far as I see, like there is a huge gap between whatever we study and when we enter into a company or any software company. So there is a gap which has to be filled in, so that students, as soon as they get into the company, they are not able to like directly work on a project. Rather, they have to be given certain kind of trainings or some kind of a session so that they can bridge that gap, and then they can be like involved in any of the project or new product development. So being a software engineer for almost like 17 years, I have worked in multiple companies. I worked in Dell Forster Networks, then I worked in HCL, then I worked in Recent Technologies. Now currently I'm working in Tekion India Pvt Ltd. So this is a startup company. So my initial experience was with, so I joined as a fresher in Dell Forster Networks, wherein I was actually working as a device driver person. So where I was responsible for developing device drivers. So I'm pretty sure like you would have heard this device drivers related uh, terminologies in your curriculum. So device driver is basically like it's the kind of a software program which actually interacts with the hardware. Let's say, for example, if you want to like have this Ethernet card to be working, so you have to program that Ethernet card so that it works as expected. So all those kind of programmings will be taken care by the device driver team. So I was actually part of the device driver team when I joined my first company. So that was my initial startup. Then I was working in different teams. Like I was working in layer 2, layer 2.5, layer 3, and then I was also working in I basically I worked in multiple devices. For example, let's say you have the router in your house or college, right? So this router actually connects to a device in the exchange, so that you call as a DSLAM. So I worked in DSLAM device. Then this DSLAM is actually connects to a edge router. So and then that edge router will get connected to a core router. From the core router again you have the multiple routers in between, and then you will have the edge router. From there again you will have this DSLAM. So that is how your let's say you connect to a broadband, right? So the network traffic goes via all these devices. So I have worked in like each of the devices, like so basically I have worked in layer 2 of this networking stack. So that is how I started my career. So I was fully into the embedded C development, and then I switched my career 2 years back. Like 2020, I joined this Tekion India Pvt Ltd. So this is a different domain. It's actually a application domain. So where they develop applications for the dealer management system. So Tekion is actually kind of uh, I've developed a single solution wherein, let's say, we have Kun Hyundai showrooms, right? We have multiple car showrooms here. So each car showrooms actually may has different softwares in different departments. For example, you have the sales department, you have service department, you have parts department. So all these departments, they have individual softwares, and they maintain lots of like what to say, like you maintain a lot of records. Like, I mean, the paper documents to do daily activities. For example, if a person comes for a service, right, they fill up a form, everything they do it in a paper document, and then they take lot of printouts. All these things are there. So and also the DMS, whatever they currently use it, it is not famous in India as such, but it is in US and other parts of the country and in the world. So we have lot of the dealers which is using the dealer management software. So Tekion as a company, they develop dealer management software, which is a single solution which caters for every department. So all the department softwares are integrated into a single software, and each module can interact with each other, so that we could get a lot of analytics out of it. Let's say, for example, a dealership in North America is able to sell a lot of parts with respect to, let's say, there are a lot of brakes are required. So we can get a lot of analytics from the this particular software. We call it as an ARC software, which is like automation retail cloud. So we are able to get a lot of analytics. Based on that analytics, we actually run a machine learning algorithm to give the dealers what is actually required by the customers, what is the need of the customer. So all those things have been taken care by with the help of machine learning and artificial intelligence. So we have a specific machine learning team, and also we have a lot of data analytics team. So we have a data platform team. Okay, so there are multiple teams working for a particular for this particular ARC module. I mean ARC software. So each of the there are responsibilities for each of the teams to do it. So as a whole, as a software company, there are multiple methodologies being followed by different companies. Okay, so when I worked in the other companies, like where I worked in the embedded software, so there is a different software management, project management aspect, and when I worked in Tekion, so it is a different software project management. So as such, if you see the normal, I'm sure you would have learned the software engineering concepts, right? Like for example, when you wanted to develop a project, you would generally choose a normal waterfall model, wherein you go with your initial requirements, design, analysis, for implementation, then testing. So this is how normal company follows. So most of the companies I worked previously, they followed this waterfall model, but in certain places we follow actually other software engineering methodologies. Like for example, one minute. So they might be using some other methodology. For example, let's say I have a hardware board, okay, and there are a lot of functionalities being like there are a lot of modules put onto the particular hardware, and sometimes we get a requirement saying that this has to be done with the help of this hardware. So what we used to do is we don't follow the normal waterfall model, because we have to go through this analysis, design, implementation, everything, and at the end of the day, let's say if that hardware doesn't support whatever we expect, then it is like it's a waste of time for us, like to do the analysis, design, implementation, everything, right? So instead of that, what we follow is like we use the rapid prototyping methodology, where we don't do we just do initial analysis of understanding the hardware specifications, and then whatever the requirement. Let's say I want to send the packet out by creating some policies. Let's say I want to send only 1,000 packets out of this particular port. Assume that. So if that is the case, there is a chip inside that hardware. So I need to understand the chip specification, and then I will have to go and program it. So I will create kind of a POC, like proof of concept, do an initial MVP product, and then check if the hardware supports that kind of a functionality. So it will be a quick work. So let's say it will be kind of around like 2 to 3 weeks of time. So wherein you can identify if the required functionality is feasible or not. Okay, so these kind of things will be carried out by following this rapid prototyping, wherein you just go do a prototype, see if it is feasible. If it is not, don't waste time. Go for a new hardware or new requirement. Okay, so that is how we do it. So I was actually involved in a lot of prototyping activities, because for in order to do prototyping, you have to be very fast. So you have to understand the concepts very in a quick pace, so that you don't have to waste a lot of time in your prototyping, and then you have to provide your result by end of 2 weeks or 3 weeks, which is not the case with the waterfall model, where you take a lot of time. Let's say uh, you have a strong, I mean, document of the list of requirements to be taken care. So that will be done into phases. So you will go into the analysis phase, where you do the initial analysis, requirement analysis, how much it is feasible, or what is the current architecture of the system, how you can fit this particular requirement into the existing architecture, or if you want to remodel your existing architecture. All those analysis you will do it in the analysis phase, and then in design phase. So your majority of the time will be spent mostly on the analysis and design. If you are able to do the analysis and design in a proper way, the coding time should not take much. So because if you don't spend your good time in analysis and design, obviously you will end up redoing your code. Because let's say there is a requirement, for example, currently in Tekion we are actually developing a tool called task management. Okay, so this is something like for every company, right? They manage their project using some project management tools. Okay, for example, we also use Jira. I'm not sure if you all have heard about Jira. So Jira is a project management tool, wherein we create projects, and then to collaborate between teams, right? We would necessarily need a board. I mean, board in the sense it is a kind of a software board, where you can put all your requirements related tasks or stories. So they call it as like stories, epics. So I'm not sure if you are aware of all these terminologies. It will be kind of new to you, but just understand from the layman perspective, like epics, there it will be kind of epics, stories, tasks, subtasks. Okay, so your requirements will be categorized into these things, and then let's say requirement is being given. For example, in task management, we have a number of features. For example, if you want to develop a email notification feature, for example, okay, so what we do is like we get that requirement, we do initial analysis. For example, email can be sent. For example, if I do something on a task, I need to send to an email to whom? Is it to an assignee of the task, or is it to a collaborator of the task, or to anybody in that project? So all these are the use cases. Okay, so you need to first of all understand all the use cases before you code it. So that way you are able to do initial analysis come up with what are the list of use cases. So the use case I mean is that the the actions that can be performed by the user and what will be the like consequence of those actions. Let's say I click a button, what has to be done on the background. Okay, so whether it has to go to a database and then update a record, or it has to send an email, or it has to do some other action. All these things has to be like categorized as a use cases. So you have to like analyze all these use cases, come up with a list of functionalities that has to be taken care, so that while you start coding it, it will be easy for you guys. You don't miss any use cases. So end of the day, it will be you should also develop a code which is scalable. Let's say today I create a software, let's say task management tool. Today I create it for just for the 100 users. Let's say tomorrow, if it is going to be used by 1,000 users or 10,000 users, will your software work? So those sort of questions you have to like ask yourself, think on those perspectives. So in terms of scalability, in terms of kind of a generic way of coding it. Let's say if you are developing something specific to a tool, it will not be a sustainable one. Rather, you have to develop your software so that it can be used across multiple modules. For example, I can give an example of, let's say, custom field. Okay, so if I say custom field, okay, so how do I say that? Okay, so in a for example, you can see Amazon app, right? So you have a lot of menu items. For example, let's take a category, electronics is an item. Okay, so in electronics item, there will be fields specific to that particular electronic gadget. Okay, for example, if you take a mobile, so it will be like what is the price of the gadget. So there will be certain fields which will be common across different products. Okay, but there will be fields which will be specific to the product. Okay, so these fields, when you think it from the programmer perspective, it cannot be like static, right? It should be a dynamic one. For example, let's say if I take electronics, you would ask, for example, what is the mobile model, what would be the screen size, what would be the display, what would be the RAM size, what would be the memory, what is the processor. All these are like specific to the electronic gadget. But let's say Amazon is also selling dresses, right? If you take dresses, again, price is going to the same. Description of the product is going to be, so there will be a description field, there will be a title field. So these are all like common. But if you take the shirt, there will be specific fields for shirt. For example, what color of the shirt is, what is the size of the shirt is. So all these are like specific to the particular product, right? So you cannot have all these as a static field. So you need to have a dynamic field. That is what you call as a custom field. Okay, so if you get a requirement something like this, you have to build those kind of a custom field in a generic way. So we call it as a platform. So platform in the sense, you should not build everything as a product. You should build some of the things into a platform, meaning it can be reused across multiple products. Okay, so when I say custom field, this custom field can be used in e-commerce software. This custom field can be used in task management software. This custom field can be used in some other project management software. So you have to think of a solution in a more scalable and a generic way so that this can be reused. Okay, so the main principle of like implementing a software, right, it is to reuse your code. So you should invent new things, and at the same time you should also try to like write your code so that it is becoming reusable. Okay, it should be a reusable component. That is what I call it as a platform or a library. So it should be a reusable one, rather than you go do specific things and then it is not reusable across different products. Okay, so for example, in Tekion, we actually developed like products like task management. This is a kind of a project management tool, and then support portal. This is kind of a support ticketing tool, wherein, let's say you have a product, for example, Amazon product is there, I mean the app is there, right? So if there is any problem with, let's say you ordered some products, you are not getting it, or you got a different product, or you got a product which is kind of damaged, you wanted to report this issue, right? So to report an issue, like what we used to do from at least from our side, we just call them and place a ticket, right? But in the America or some other countries, what they do is like they write email, let's say support at amazon.com or support at tekion.com. There will be some email IDs for supporting the customers post the sales. So this is a tool which we built it internally. And then we have one more tool called CRM. I think most of you would have heard Salesforce, right? So Salesforce is a CRM tool which is like a customer relationship management tool. So which can like create I mean, there are a lot of stages in CRM, so I don't want to discuss about that. So this tool is mainly used for having a good relationship with the customer. That your customer can be another business, or your customer can be your end customer. For example, the dealers, whatever I talked about, their customers actually end customer. But for Tekion, dealers are the customer, but that is another business, right? So we have B2B CRM. So and then we have another CRM which is a B2C CRM. Okay, so B2C is different, B2B is different. So but we cannot build like there will be specific components which is specific to B2C, and there will be specific components which is specific to B2B. But there are like common parts which are like can be shared between B2B and B2C. So that is what you have to build it as a library. Okay, so when you build something, you just have to ask yourself a lot of questions, or if you are not aware of it, you should ask maybe your leader, your colleagues, so that you can like convert that requirement into multiple use cases, see if you are able to cover all those use cases, and then come up with a better solution, rather than restrict yourself to the requirements whatever given by your product team. Okay, so to talk about the other team members, right? So how you get the requirements, and what happens in from the development perspective, and how it is taken care, and how it is given to the testing team, and finally how you get the product. Okay, so I'll just talk about that. So in each and every company, right, there will be like product owners. Okay, so they do they are called like product owners or product management teams. Okay, so PM team basically. So they get the requirements from the stakeholders. The stakeholders can be a person, a stakeholder can be another company, a stakeholder can be an client company. So since I worked in both product based company and service based company, so for me, right, in a product based company, this particular product management team will talk to the end customers. For example, Bell Forston sells their routers to Google. Okay, so Google is the customer, so they get the requirements from the customer. So why do we need a product management team? Is because Google may not know, I mean, the customer may not know the technical jargons or technical things. They just give requirements from their perspective. Okay, it will be a normal English words, but for the developers to understand, or for the technical teams to understand, right, it should be converted into like the technical specifications or technical requirements, so that the engineering team is able to understand the requirements, do the analysis. Okay, so that is why we have this product management team or the product owners. So they take the requirement, they create something called a PRD document, which is the project requirements document. Okay, and then they hand it over to the engineering teams. So the engineering team does the analysis, design, and then based on the technical feasibility, they come up with a plan, like when it is feasible to give the product as a whole. Okay, then comes the testing team. So the testing team will carry out a lot of testing. For example, if it is going to be a new product, so it is going to be developed from the scratch, so you will have to have everything from the scratch, meaning you have to do your functional testing, you have to do your scalability, integration, stress, all those things has to be taken care. If it is going to be an addition to the existing product, right, obviously you will have the test suite available. Let's say you are bringing in a new feature, so what the testing team will do is there will be a lot of teams inside the testing team. So some some people might do the functional testing, meaning let's say you developed some feature, okay, so that team will be testing only that functionality, okay, what are the feature we have developed as a new one, so that will be tested by the functional testing team. And then the regression team, what they will do is like after you put that new functionality, is it going to break the existing ones? So those things will be taken care by the regression or the sanity testing team. And then the integration testing team, let's say your tool is going to like interact with some other tool, so the interaction between your tool and some other tool, or maybe within your tool, if it is going to interact with multiple modules, all these integration testings will be carried out by your integration team, okay. So these are the different testing teams is there to carry out different sets of testing. So we follow all this process so that end of the day you give a quality product. So and also we have like lot of quality metrics wherein, let's say I do like 1,000 lines of code, I can at the maximum like give only like 2 or 3 bugs, okay. There are like quality metrics, so you cannot write like 1,000 lines of code and have like hundreds of bugs in it, so that's not agreeable. So for every software developer, there will be quality metrics in terms of the number of lines of code being published, or the number of hours taken for the implementation of that particular feature. So all this will be taken into consideration, and then only you'll like give the end product. So this is how the flow goes. So mostly the startup companies are the companies where we wanted to develop a product from the scratch, but get into the market in a very faster pace. They follow something called an agile methodology, okay. So in agile we follow a scrum process wherein so the scrum is the like kind of very when you want to develop something very fastly, right, we follow the scrum process. Most of the companies now they are adapting to the scrum because company wants everything to be delivered in a faster pace so that they enter into the market, and then they are able to like fetch the revenue out of it. So that is why they use the scrum model. So scrum in scrum you basically have a lot of scrum related jargons like scrum master, then daily stand up meetings, and then your retrospective meeting. All these are there. So in basically what we do in scrum, right, so we get the requirements, okay, we analyze the requirements, split that into different stages. Let's say for example you have a bigger requirement, you don't take the bigger requirement as a whole, do it like similar to your waterfall model, because if you do that way you will have to wait for like 6 months or 1 year or 2 year, we may not know. But if you go for a scrum model, right, what they do is like they take this bigger requirement, split it into chunks, okay, and whatever is required for the MVP, the minimum viable product, they take those requirements, develop it in like 2 to 3 weeks of time, release it, okay. So they go by chunks, take the requirements, split it into chunks, release a product with this little features, so that we're able to see the progress in a very fast pace. And also there are possibilities for a lot of innovations in the scrum model rather than the waterfall model. We go like process, we take like 6 months or 1 year, but end of 1 year, if we see the result, it can be good or bad, we may not be able to measure that. But if you go for a scrum process, we will be able to like get the result within like 2 weeks or 3 weeks of time. So and also they do a retrospective meeting wherein, let's say on a particular sprint, so everything is run as a sprint, okay. So scrum is a methodology, and inside scrum you have a lot of sprints. So for every sprint, let's say you have a bigger requirement that is split into like say 200 200 sub requirements, okay. So this 200 sub requirements will be like splitted based on the what is required first and what is required next. So they will split into chunks. So each sprint let's say we can take up like 20 items first. So as the team gets knowledge on the initial requirements, the team will be able to understand the product in a better way. So as they go on each sprint, they gain a lot of knowledge. So initially they take up like 20 items, and as they progress on the other sprints, they will take like 30, 40. So the team's performance also will drastically increase, and you will able to see like in a real time, like the team has improved a lot in terms of the understanding the product, in terms of implementing it. So all this can be easily visualized, or easily can be seen when you follow the scrum model. Okay, so that is why most of the companies they follow the scrum model, because they are able to like easily find out what is the problem in the way it is implemented, with I mean handling the teams where the problem is, and what kind of actions can be taken, so that we can rectify this problem and come up with a better approach. So that is what most of the companies do, and we also do the same thing. So sprint will be there. So each sprint there will be a sprint meeting. So in sprint meeting we discuss on what are the list of requirements that has been taken care for that particular sprint. So that will be put as a task in the project management tool, whatever I said you, like Jira project management tool, they put as a task, and then it will be assigned to the developers. And so the developer pick up the task. What they do is like they put the story points. For example, a story point is a little complicated thing, but maybe we can understand like when you go into the job. But I'll give you a like brief description about it. So story point is something like how many, what is the complexity of that particular requirement, and how much time it will take to complete that particular requirement. So this is the simple definition of a story point. So the developers will give a story point to develop that particular requirement, and also the QA team will also give the story point to test it. Okay, so they have to write the unit test cases, they have to write the automation script, so that as and when the requirements are done, they can run this automation script, identify the list of issues, and report it to the engineering team, so that they can fix it and then deliver it. So the story points is the one which is going to give you the number of hours or number of days to complete that particular requirement. So based on that, the product teams will plan the next set of features or requirements to be accomplished in the subsequent sprints. Okay, so this is how it goes. So the product teams will organize a scrum sprint meeting, wherein they will discuss the list of requirements to be accomplished for that particular sprint. The engineering team takes up this list of requirements, put the story points, and then do it as per the like ETS promised, and then the testing team comes into picture. In parallel, the testing team will start developing the test cases, the automation scripts, all those things will be done in parallel. And then once the code is deployed to your production environment, I mean it will not be deployed to directly to the production environment, there will be different environments. So we will have a stage environment, we will have a test environment, so they do testing in different environments. And then once it is certified by the QA team, the testing team, it will be finally pushed to the production, and post that there will be support teams to take care of the issues post your production go live. Okay, so this is how it happens, and this is what we follow from the any company. For now, we are following it in Tekion. Similarly, some other companies also they follow the Scrum methodology to work on the new products or existing products. So this is how it goes. Any questions or anything you wanted to discuss? Students, you have any questions? I hope you guys listen to my conversations, right? So feel free to talk to me. Maybe if you are feeling shy to talk in English, you probably can talk to me in Tamil also, not an issue. But just I just wanted you to talk so that I can able to understand whether you guys really understood whatever I have spoken till now. No questions? Ma'am, I'm done. So anything I have to cover, or is it okay?
It's okay, sir. It's very good presentation. Sir, my doubt is how to select this software life cycle model for projects, and which life cycle model is very good.
Yeah, if it is going to be okay, since I worked in multiple software companies, right? So mostly the embedded companies, they choose waterfall model. Why? Because it has to be done in stages and different teams are involved. Again, let's say for example, Cisco as such, because since most of you would have heard about Cisco, right? So Cisco, when they do a new router or a new product, right? So in a router, there are different hardware parts, components are there. So they call something like line card, which is kind of, it will be like it will have lot of ports. It can be an Ethernet port, it can be an optical port, or it can be an E1 T1 ports. Okay, so based on the requirement from the customer, let's say for example, for Cisco, they will get requirements from a lot of ISPs or a lot of the networking. I mean, the companies which are providing the cloud solutions or the ISPs, right? So they give the requirement. For example, for some companies, they might require 48 port Ethernet card. For some companies, they might require a 16 port Ethernet card. So based on the requirements, so they create the board. So this cannot be done as a scrum, because you cannot do this as a scrum. Basically it's a hardware project, and again, it is not about the hardware project. The amount of time it takes to complete that hardware project is very high. So you cannot do scrum model here. So we have to follow the waterfall model, because we have to invest a lot of time in the initial requirement gatherings, and then we have to invest a lot of time in analysis and design. So you follow the waterfall model in this aspect. But when you want to so for example, for this rapid prototyping, as you said, right, you have an existing hardware, okay, and there are a lot of chipsets or a lot of components in that particular hardware, okay. So for example, let's say you wanted to, so there is something called I don't want to stress more on the technical part, because it will be kind of confusing you. So on the layman terms, right, so let's say from the router, there are like lot of traffics will be going out of the router. So on a particular port, let's say there is a 100 mbps port, the capacity port. So you want to send out packets from it. So in a packet, right, there will be different queues, meaning some traffic will be having highest priority, some will be having lower priority. So you cannot send every packet out, because uh, high priority of packets take more precedence than the low priority. For example, let's say you are streaming the video, right, you are seeing the Amazon video, okay. So if there is a delay in video, you cannot visualize that, right. So it has to be it has to have a high priority. So from the hardware, the priorities will be as there will be priorities configured on the hardware, and based on that, it will be put into the queue, and from the queue it will be sent out of the physical port. So let's say there is a requirement which says that there is a high priority, there is a medium priority, and if I want to allow just the a packet which is having priority in between these two to take precedence. So first I have to do I cannot follow waterfall model, because already the hardware is there, the support is there. Just I have to go and program the hardware, so that I can check the feasibility study and see that if it is possible or not. So there I will use this rapid prototyping. Okay, so I'll just do like 1 or 2 weeks of coding effort. I'll see if it is feasible or not. If it is not feasible, I'll drop off the project. I'll have to create a new hardware. So wherever you have the hardware, you have a lot of processors or modules inside the hardware. You have to, if you want to study the from the hardware spec, they would have, from the hardware team would have given you the spec, but still from the programmers level, you have to identify if it is really possible to program it the way we expected it. So there we use the rapid prototyping. We don't use the waterfall model. And then when you go to the scrum model, mostly the scrum model are actually suitable for most probably the software projects. Okay, so because software projects are like, you get a requirement, you do it in a fast pace, and then you get another requirement on top of it. So and since it's purely software, right? So you can tweak it, or you can revamp your entire architecture, because you, whatever that you have done earlier, you have to redo it again. So it is kind of continuous learning process you have to do when you take up this scrum, I mean the sprint models. So if you want to develop a software in a faster pace, and you are not sure of the full requirements, you go for a scrum model or you go for a sprint model. So this is how we choose it. So mostly I worked in both, like I worked in all the three models, like waterfall or rapid prototyping or this scrum model. So it depends. So it depends on the company as well. So mostly most of the software companies, the application based companies, they choose the scrum model, and the embedded companies, they choose the waterfall model and the rapid prototyping model. So that's how it goes. I
Thank
hope.
you so much, sir. Thank you so much.
Yeah.
It's understood. I have understood that concept. Thank you so much. It's wonderful presentation.
Yeah.
Saravana Priya, are you there?
Ma'am, before that, I'm not sure if your students are feeling shy to talk over this call.
No, sir. No, sir. They are very interested, but this is the first time we are conducting the guest lecture on this
Okay.
topic.
Okay.
And the students or the participants are from AAML Club. So they are eagerly to do the projects
Okay.
in AA and ML.
Okay.
If any problem statements, if you have, you can give it to them. They will do the projects. And this is the second year students, so they are not having such much of knowledge.
Okay.
So,
Yeah, we
and
have a lot of real-time requirements we get it for AI or ML. Okay, for let's say for example, in Tekion we are actually trying to do a project. I can give you a real-time example. So there are a lot of hardware products available on the market to, let's say, when you give a car for the service, right? What generally in India we do is, right, we take a picture of the car, so that whatever the condition I give the car, the same condition I have to get back, but it is serviced in a proper way. Let's say, for example, my right side mirror, when I give service, when I give my car for the service, right, my right side mirror is kind of scratched or has some dent, no? So they will take the picture out of it and then have it, so that when they return back, they don't make any scratch or dent on the car. So it's only whatever it is done by me, it is there. So that they have to ensure from the dealer side, right? So there are a lot of hardware products available to like take it, rather than a person going to the car and then taking a picture and then showing it, or like it's kind of a manual work, right? Instead, there are some products which will take the picture and then upload it to your cloud software. So it is there. But what we are trying to do is, right, so those hardware are little costly, like let's say it can be like $1,000 or $2,000, $3,000. So what we are trying to do is, right, we are trying to do it using a camera, high resolution camera. So this camera will be placed on the service lane, like the car will enter the service lane. So the cameras will be placed in the two places on the both diagonal sides, so that the camera can take the pictures of the entire car, and this pictures will be fed to a machine learning algorithm. So this algorithm has to identify the dent or scratch in the cars. Okay, so this is project or product we are trying to do in Tekion, so that this becomes a cost efficient, and also you can do a lot of machine learning algorithms to like handle the scratches and dents, because in US, right, there are a lot of problems being created. Like I give a car, there'll be scratches and dents are already there, but even then the customer will come and fight that you guys have put a scratch, or you guys have put a dent on my car, you have to repay for miss, otherwise I'll go to the court or I'll sue you. So all these kind of problems will be there in US dealerships. So that's why they wanted to have a they install these kind of a product. So already there is a product, but that is all like very high cost. So we want to give a low cost solution, and again an effective solution. So that is where machine learning comes into picture. So the pictures or the data sets will be fed into this machine learning algorithm. So this machine learning has to like be trained so that it is able to effectively identify your dent or scratch in the car. So this is a real time example. Probably I think your guys, your students can try out from their own, because everybody has a camera, right? They can use the phone camera also. They can take a picture from any car. They can train their machine so that it is able to identify, okay, this is the dent, this is a scratch, or this is the intensity of the dent. Let's say, for example, the dents can be very high or low, so it should be able to identify what is the like depth of the dent. And then scratch, if you take, it can be a slight pen scratch, or it can be a scratch which is like making the rust on the car. So different scenarios are there, so your machine has to be trained to address all these scenarios. So that is why I said, like, you should identify the list of use cases. So that is what I call it as a use case. So first of all, you have to identify the list of use cases, then you have to proceed with your development. Because if you don't identify the use case, and when you go into a real-time scenario, you might hit a use case which you have not programmed it, right? So, and that will be a buggy product. So you have to think of all those use cases. So this is such type of a real-time requirement, I would say. So maybe if anybody is interested, they can start doing it. And also, if required, I can also we can also get involved. We can collaborate and do it also. That is fine. I'm happy to help on that.
Okay, sir. Shall we put the MOU with you for developing the software? Is it possible, sir?
Ma'am, that I'll have to check with my director, because
Director, okay. Okay,
so
sir. Okay.
I can have a word
Okay.
with him. That's not an issue, but
Okay.
I cannot straight away commit that. So
Okay. Okay,
yeah,
so no problem. We need a offline session because
sure.
your presentation is very good, understandable format also. So I need one offline session. If it is possible, you send me that confirmation letter. I will send the requestation letter through the HOD mail.
Okay.
So please confirm whenever you are free. Thank you so much, sir. Saravana Priya, are you there? Saravana
Yes,
Priya?
ma'am.
Okay, you continue.
Sumita, over to you.
I deem it great honor and privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making this occasion a resounding success. Respected Secretary and Correspondent Dr. P. Chinnadurai, MA PhD, and our directors Mrs. Vijay Rajeshwari, Dr. C. Shakti Kumar, ME PhD, Mr. Saranya Shakti Kumar, BE MBA, Honorable Chief Guest Mr. S. Chandrasekar Sir, HOD Dr. Jabashila Ma'am, and Dr. Kavita Subramanian Ma'am, our AIML Club Coordinator Dr. Josephine Leela Ma'am, faculty members and fellow students. A wide round of applause and thanks to all who made this webinar a very successful and memorable one. Finally, I'd like to thank all of you present here for making time with us today and helping us make this event a great success. Thank you.
Thank you, sir. Thank you so
Thank you,
much.
ma'am. Thank you, students.
Students, you can leave. Any questions if you have, you can ask. Okay, sir. Thank you, sir. Thank you so much.
Thank you, ma'am. Thanks a lot. Bye.
Bye, sir.
Thank you, ma'am.
Thank you.